Hello, this is a short unit on groundwater, maybe a review, maybe new to you. The course is on surface water, really on stormwater, but one of the main ways we want to get rid of stormwater is to infiltrate it into the ground. So we do need to know how water moves through the ground. I do have another whole course on groundwater, and that we also take a look at how chemicals move through the groundwater. But this will give you some of the basics on how water moves through the ground. So I'm showing here, and there's these notes you can available to you. You can follow on along and take notes on those. I'll also provide you with the filled-in notes. So this shows a cross section of the ground here, and if I dig a hole in the ground, a well is a hole in the ground. This shows a well casing, a pipe I put down in the hole in the ground, and then I have a screened interval where the water comes in. There's a screen there, and I can show you more details of how it's actually finished out, but this is a well here. So if I dig down, I'm going to have dry-ish soil. So there is some water up above here, but at some point, if I dig this hole and I get into the water and I let it sit for a bit, I'm going to have standing water in this hole, if there is groundwater there. So I will draw that right here. So that's the water level in the well, and I'll draw my little symbol here to show that's the water level. And if I do that at another well down here, so maybe make this one about there, maybe. So again, I'll show my water level there. And I have this soil here, and I'm going to kind of assume that in between there, if I'm in the same formation in an aquifer is a formation in the ground that gives you water. Not everything gives you water, but if it gives you water, that's an aquifer. And I'll come back to what we mean by unconfined in just a second here. So if I draw here, that'll be the water level along there. I didn't draw it perfectly there, but that would be the water table. Below that, we have the saturated zone. And above that, we have the unsaturated zone. Now, there is some water in the unsaturated zone, and the water can move there. That's also, by the way, called the vadose zone. I don't know where that word comes from, but sometimes we usually just call it the unsaturated zone. So this is what we call an unconfined water table. I mean, it's not confined at the top. It is confined at the bottom. So at the bottom, we have the confining layer. This is rock or clay that will not let water through. We say it's impermeable, not permeable. We might also call that an aquiclude. This is a water table aquifer. So if it has a water table, and again, in a minute we'll talk about a confined aquifer, it's unconfined. So we have here the couple things we measure here. We measure the head is measured from the confining layer up to the water table. So we have the head moving from up here to down here, and water flows downhill, or down gradient, most accurately. So the change would be the change in head. There, the delta H. Now we could actually come down and hit some water above. We think we're hitting good water up here. And then we pump that, and then it's gone and doesn't come back. We might have put a little layer under there. We may have hit a perched water table, or a perched aquifer. Better way to say it, aquifer. So we have some perched water up there. So that's an unconfined aquifer. By the way, the water in the ground comes from the surface at some point. You had to get there somehow. and it can infiltrate down in the ground and get in there. And then if it's sloping down that way, the water is flowing in that direction in general. I'll probably say this again, but groundwater flow is three-dimensional, so it can flow in the vertical direction as well. Kind of assume most of the time it's going horizontally, but it can also go vertically. And actually, some of the examples we'll do in the class later on, we have it go vertically. Impermeable. Can't read that very well. All right. So that's an unconfined aquifer, also known as a water table aquifer. A confined aquifer has layers on top and bottom. So we have confining layers on both the top and the bottom of the aquifer. So at the bottom here, we have a confining layer. Sorry, at the top, confining, and confining layer on the bottom here. So if I drill down here and drill through this layer here and put my screen down in here, the water comes in here, down here. It can't come up here. I'll say this a couple times, but so this well doesn't tell me anything about happening. I might have an unconfined aquifer up here as well, but now I'm tapping into a confined aquifer down deeper. And if I drill that hole in there, I screen it down here again so the water comes in between these two layers, not there. And let's say it comes up to maybe about there in my well. And then at this well, it comes in, I do the same thing, and water comes up to there. This is not a water table because this does not tell me what's happening between those up above this confining layer. It tells me the pressure between those down here. So these are under pressure. So I think I say that a confined aquifer, I'll make a note here, is by definition under pressure. These wells don't tell me anything about what's happening here, but I want to also use my principles of water flows downhill. I might draw a dashed line there. I'm drawing it dashed to show that it's not actually water there. This is the head of across this direction here. So we might call this the potentiometric surface. Potentiometric surface. It's not actually the water, but if I drill wells, holes in between here, that's how high the water will come. So that represents the potential or the head between those. And if it's coming, again, water flows downhill, going from there to there, that means my water is flowing in this direction. And again, I have these two impermeable layers. So these are impermeable. They can actually be a little bit permeable. So if you have a clay or a rock, it's not all or nothing. It can be really, really slow and be almost impermeable. In that case, we might use the highly technical term leaky. So it's more permeable than the stuff above or below it. Well, we care about the stuff above it for our confined aquifer, but it might leak through. So the ground in general is kind of laid down and it tends to be laid down in layers, and some of these are more permeable than others. And if you have some permeable layers and then they're confined by some really impermeable layers, then you have a confined, and there's water in there under pressure, then you have a confined aquifer. And it matters because the math is a little bit different for them, and how we get the water out does, wait a minute. So if I pump the water out of here, all the water drops down, right? I pump the water down here. This aquifer is full of water when I start, and it's still full of water after I get water out of it. So where is it coming from? But the head will drop. And again, we will define the number we need. We need the length between these, and then again, we need the change in head to find the gradient there. By the way, if the pressure is high enough down there that we actually have water coming out the top. This can happen. You like thing with the oil. We hit oil and it's oozing out because it's under such high pressure. If that happens with water, if that happens, we call that an artesian well. Now that word is used a little bit loosely. Sometimes people just use artesian for any confined aquifer, but I think a more rigorous definition is if it comes out with the surface. And we can have, this surface can go down, so it might be coming out in some places, not coming out in the other. For either of these, if it's leaking out, if the ground surface comes down and the water's leaking out, then we have a spring or a seep or something like that. All right, one more thing, a number that we'll need is the aquifer thickness. So the thickness of that aquifer, which we need that for volume calculations and stuff, we call the aquifer thickness, and we usually use a B for that. Aquifer thickness. All right, that's a short overview of the aquifers, a unconfined aquifer or water table aquifer, and a confined aquifer, which is squeezed between two impermeable layers. And in our next one, we'll go into the fundamental law that governs everything on groundwater transport, Darcy's law, and then we'll have a couple exercises on that. So I'll stop this one now.